Hello, my name is Rick Finley, and my project is on Affine Geometry. Yes, Miss Brewer, I am using my phone to do this because I could not find a way to use Teams, and so I just thought, hey, I'm just use my phone. And I apologize if the camera's a little bit shaky, but I'll try to get through it the best I can. What is affine geometry? Well, affine means to be related to a transformation, such as a translation, a rotation, or a uniform stretching. They carry straight lines into straight lines, parallel lines to parallel lines, but may alter distance between points and angles between lines. As one can guess, this is the basis of affine geometry. Affine transformations are used to preserve the lines of parallelism, and affine geometry is also known as the study of parallel lines itself. And then we have the history of affine geometry. A.F. Möbius, in the first half of the 19th century, was the first to study the properties of geometric images that go over into each other as a result of affine transformations. However, the concept of affine geometry only arose following the appearance in 1872 of the Erlangen program, according to which each group of transformations has its own geometry, the subject of which are the properties of the figures that are invariant with respect to the transformations of this group. The group of affine transformations contains various subgroups. As a result, in addition to general affine geometry, we have subordinated geometries, equi-affine geometry, centro-affine geometry, etc. arose, corresponding to these groups. Affine geometry also deals with problems of differential geometry corresponding to specific transformation groups. Sorry about that. Affine transformations. Affine transformations combine linear transformations and translations. Due to this, the origins of the original and warped shape do not always map out the same, but ratios are preserved, and all parallel lines stay parallel. An example of affine transformation is how satellite imagery uses it to correct for wide-angle lens distortion, panorama stitching, and image restoration, transforming and fusing the images to a large, flat coordinate system is desirable to eliminate distortion. Then we have different types of affine transformation. First, we have translation, and a translation moves every point of a figure or a space by the same amount in each direction. Think of just moving a shape to a different location. Let's say on a sheet of paper you have a square in one corner and you move it or redraw it to the other corner. That's essentially what translation is. Scale is just the general change in size. Think about when you're on a computer and you insert an image onto, let's say, a PowerPoint or a general document, but you wish to enlarge the image, and so you do so. That's what scale is. You're changing the overall proportions to make it bigger and or smaller. A transformation in which all points along a given line remain fixed, while other points are shifted parallel by a distance proportional to the perpendicular distance, is called a shear. Now, a shear is when it's a bit more complicated, but still a bit simple. You're basically just changing the overall form of the figure. Think of turning a square into a rhombus, but you keep all the sides to the same length. Again, that's how the parallel lines stay the same, and all the general points are the same as well. And last, we have rotation, or turn. Is a transformation that turns a line or a shape around a fixed point. Think of, again, a square, and you rotate it. Instead of the flat sides facing up, down, left, and right, it's instead the points. That's a basic form of rotation. Affine space and vector space. An affine space is a geometric structure that generalizes the affine properties of a Euclidean space. And in an affine space, one can subtract points to get vectors, or add a vector to a point to get another point, but one cannot add points. In particular, there is no distinguished point that serves as an origin. The solution set of an inhomogeneous linear equation is either empty or an affine subspace. A vector space is a set that is closed under finite vector addition and scalar multiplication. The basic example is dimensional Euclidean space, where every element is represented by a list of real numbers. Of real numbers. Scalars are real numbers. Addition is component-wise, and scalar multiplication is multiplication on each term separately. And we also have the affine functions themselves. Affine geometry has different functions for different dimensions, such as y equals ax plus c for one dimension, f times xy equals ax plus by plus c for 2 dimensions, and f times xyz equals ax plus by plus cz plus d for 3 dimensions. And these are my sources. Thank you for bothering to watch my presentation. I know I said there would be Power Rangers, but sadly, I could not find a way to properly incorporate them in. But for anything else, I'm balancing this on a Chewbacca mug. So once again, thank you, Miss Brewer, and I hope you have a good day.